already know what we need to do when it comes to, if I have the same base, and then what do I do with the, and I'm multiplying, what do I do with the exponent? I have the same base, and I'm dividing, what do I do with the exponent, and so on and so forth. So we're going to look at a little bit more, right, into the exponent law and what else can I figure out from the exponents. So if I have the bases 1, 2, 3, 4, these, and then I have them to the power of 2, right? It's like I'm doing 3 times 4. Or I'm doing 4 times 4, 5 times 5, right? So that's what the square means. And then I should be getting 9, 16, 25, 36, and 49. Okay? So this is the exponent 2. Now what happens when I have an exponent of negative 2? Exponent of a negative 2, what does that mean? What does that do to my base? So if I have 2 to the power of negative 2, I have to flip my base and make my exponent positive. Do you guys remember that? So that would be 1 over 2, because if I flip my base is 2, flip it, that would be 1 over 2, and then to the power of positive 2. So it's going to be 1 over 4. So what would I have if I have 3 to the power of negative 2? 1 over 9, because 1 over 3 squared. 4 to the power of negative 2? 1 over 16. 5 to the power of negative 2? 1 over 25. 6 to the power of negative 2? And 7 to the power of negative 2? 1 over 4. Okay? So we know that negative exponent makes the base flip to become, and then it becomes a positive exponent, and then I can evaluate using fractions. Okay? Usually I would want you to use fractions and to keep it in fractions. Unless you're graphing, then you can change it to decimal so you can kind of precisely graph. Now, on your calculator, you're going to do 1 to the power of a half, 2 or 4 to the power of a half. So now our exponent is a half. So when you do that on the calculator, you're going to do this. 4, you're going to put your exponent in, and then you're going to put your half as 1 over 2, but in bracket. If you don't have a good calculator, this is, or if you have like the decent calculator, what if you do 0.5? You can do 0.5, but later on when we like use other fractions that are not like just to one decimal place, it's going to be trickier to do that, so that's why you need to learn how to do it with brackets. Okay? So what do you get when you do 4 to the power of 1 divided by 2?
Can I do this?
No, I think it could be because it's using the fraction. Try 9 to the power of half. Depends on some calculators.
Just a half, let's put 1 over 2.
Same thing that you did. Yeah, but with a 9.
Okay.
Same thing what you did.
By 1. By 1 to the square root.
What? Okay, so put in bracket. No. Put it in bracket. Yeah. Okay, so what do you get when you get 9 to the power of a half? 3? 3. And then 16 to the power of a half? 25. 36 to the power of a half? 49 to the power of a half. So if I did 4 to the power of a half, I got 2. And 9 to the power of a half, I got 3, and so on and so forth. What do we know about 4, 9, 16, 25, 36, and 49? It's the same thing as square rooting, right? So to the power of a half is the same thing as a square root. Okay? So I could have done this and got the same answer. I could have done this and got the same answer. Okay? So power of a half or a square root, they mean exactly the same thing. now we're gonna change our exponent a little bit. Okay? So our exponent is 3, -3, and at 1/3. So if I do 3 to the power of 3, I'm gonna get 27. 4 to the power of 3, it's 64. 5 to the power of 3, 125. 6 to the power of 3, 216. 7 to the power of 3, 343. Okay? Now, without using a calculator, if you want to find 3 to the power of -3, what do you think it's going to be? 1 over 27, because this is the inverse of the first one, right? It's the reciprocal of the first one. So it's going to be 1 over 27. Right? 4 to the power of -3 is going to be 1 over 64. 125, sorry, not 125. 5 to the power of -3. How about to the power of 1/3? So if I have 8 to the power of 1/3, I got 2. What do you think 27 to the power of 1/3 you're going to get? 3? Again, you can do this on the calculator. You can do 27 to the power of 1 over 3.
So square root again? Ah, the cube root, you mean?
Cube root? Cube root. Okay. Let's see. 24 to the power of 1/3, that's 4. 125, that's 5. 216 to the power of 1/3, that's 6. 343 to the power of 1/3, that's 7. So you guys are saying it's the same as the cube root? Try it. And you got it? You got it, right? So that's the same thing as a cube root of 27. Do you think that's a coincidence now, or do you think that's actually a correlation here? So I have power of a half is a square root. Yes, I don't put a square here because that's my, like, it's like a power of 1 basically, right? Square means square, it's called a square root, right? So that's the original root. So that's why I don't put a 2. And then when I do the power of 1/3, it's the same thing as the cube root. Is that going to be for everything? Or is that just going to be for these two, you think?
For everyone?
For everything, right? Try 16 to the power of 1 over 4. So try, and try the 4th root of 16. Are they going to give you the same answer?
16. Got 2.
How about 16 to the power of 1 over 4? Okay, you have to try both of them, right?
Syntax error.
Put it in bracket.
Okay. 16.
You got 2 as well? So guess what? A power of a fraction, okay, 1 over something, that's the same thing as the root of the denominator, okay? So if I have 16 to the power of 1 over 7, it's the 7th root of 16. They're the same thing, okay? Can you see the correlation now? So my base to the power of 1 over n is the same thing as the nth root of that base. Okay? we're gonna talk about formula on the next page. You don't have to write that one. Are we good? We've already compared the entries. So let's just write this one. The answers for these ones. So we know that the negative exponent is the reciprocal of the positive exponent. So to compare the first and second column, right? So the negative exponent is the reciprocal of the positive exponent. Reciprocal means, so if you had, let's say, 3 to the power of 2, that was 9, right? And 3 to the power of negative 2, that was 1 over 9, right? So reciprocal means the flip. That's the word for it. That's the actual terminology for it. Okay? So the negative exponent is the reciprocal of the positive exponent.
So if you find the reciprocal of.
I wouldn't ask you to find the reciprocal. I'll just give you like 3 to the power of negative 2. You should know it's 1 over 9. I don't want you to give it to me in decimal. I want you to give it to me in fraction. Right? And then if we want to compare the entries in the first and third column, we said that the third column is the root, right? We talked about, you guys saw that, and you said that the exponent half is actually the square root. And then the exponent 1/3 is the cube root. So then, if I want to write this as a general term, it's going to be the nth root of k. So here's what I want you to do for the next few minutes. You're going to fill out these two tables. You're going to use these as your bases. And then the first column is to the power of a half. Second column is to the power of 3 over 2. Third column is to the power of 5 over 2. So you're going to raise this base, the 1, 4, 9, 16, to these powers.
So 1 over 2.
To the power of 1 over 2.
1
Yep.
3 over 2.
To the power of 3. Yeah.
1 to the power of 5 over 2.
That's right. Okay? Then you're going to do the same thing with this table. Okay? And find the answers from it.